Good evening, students. Today we are going to discuss an important topic in grade 10 chemistry, mole concept, in that exercise 5A numericals. See, I'll give you a simple method how to calculate these numericals. Before that, let us see question number 4. Calculate volume of oxygen at STP required for complete combustion. You know what is meant by combustion? Burning the hydrocarbon in presence of oxygen. So 100 liters of carbon monoxide they have taken at the same temperature and pressure, and this will be your equation. So question number 4A. First let us solve A, then we will move to B. If you take the equation, always remember first let us mention the equation. After writing the equation, you need to take, earlier we were used to call it as 2 moles, now we can write it as 2 volume carbon monoxide combines with 1 volume of oxygen and forms 2 volumes of carbon dioxide. So this is your given equation. Now in the place of 2 volumes, what is given? They have mentioned 100 liters and they are asking how much of oxygen is required. So here we can take it as 100 liters. Hope you have understood this now. We can equate this very simple. For 2 volumes we need 1 volume oxygen. So for 100 liters, let us take x. Cross multiply this, what you get? 2x is equal to 100. Now x is equal to 100 by 2, that is 50 liters. So we have to add how much here? We have to add 50 liters of oxygen for complete combustion. So this is about 4A. Now coming to B, what they have given? 200 centimeter cube of hydrogen they have taken and reacted with 150 centimeter cube of oxygen, and this is your equation. Now what is being asked here? What volume of oxygen remains unreacted? So let us see the equation first. So if you take B, 2H2 plus O2 gives us 2H2O. Now if you write 2 volumes of H2 combines with only 1 volume of oxygen and we get 2 volumes of water. Now for example, what is given? 200 centimeter cube. For this let us take X, equate this. For 2 volumes, 1 volume. Now for 200 centimeter cube, how much is required? So we can take it as 2x is equal to 200 centimeter cube. Therefore x is equal to 200 by 2, nothing but 100 centimeter cube of oxygen. Hope you have understood this. We need only 100 centimeter cube. But how much is there? 150. Therefore, volume of oxygen which is unreacted, given volume 150, how much is required? 100. Therefore 50 centimeter cube will be unreacted, that is left out. One more important thing, in the theory we have discussed that, so the one which is remaining as unreacted is called as excess reagent. Now the excess reagent is oxygen here, and this one which is consumed is known as limiting reagent. Once again we are revising the terms here. So what is meant by excess reagent? The one which is left out. And how much is left out here? 50 centimeter cube of oxygen remains unreacted. Hope you have understood this. Now let us move to the next question. Now let us say question number 5. They have mentioned 24 cc, that is cubic centimeter of marsh gas methane is mixed with oxygen 106 cc. On cooling you got a mixture of 82 cc where 58 is unreacted, 58 cubic centimeter is unreacted. They are asking which law supports this, explain with the calculations. Now before you start, you know that it is combustion. Combustion of methane we can write like this: CH4 plus O2 gives us CO2 plus H2O. Now I'll explain you how to balance this equation. You know that carbon on combustion with oxygen gives CO2, hydrogen on combustion gives water. So I have written a skeletal equation, and now how to balance this. Always understand that you have to balance in the order of carbon, hydrogen and oxygen. First, 1 carbon we have here, Now on the other side also we have 1. Next, coming to hydrogen, we have 4. Hence we write the coefficient 2 here. So 2H2 nothing but 4. Check out with oxygens. How many we have here? You have 2 plus 2, 4. Therefore, finally you balance this as 2O2. Very simple. Now if you understand that, according to the law, any liquid or solid, we can ignore that. So here water can be ignored, and what is left out, we can take it as 1 volume of methane combines with 2 volumes of oxygen and forms 1 volume of carbon dioxide. Very simple, you know that this is according to Gay-Lussac's law. So what is Gay-Lussac's law here? Gay-Lussac's law says that the gases will combine in a fixed ratio. That is, what is the ratio here? 1:2 and forms 1 volume. So the simple ratio here is 1:2:1. Now we need to calculate this and explain how much is unreacted. First of all, let us write. See, the ratio is 1:2:1. Gay-Lussac's law we know. If 1 volume is there, 2 volumes we need. Therefore, if 24 cubic centimeter of methane is there, how much is required? That is nothing but x. On cross multiplication we get x is equal to 24 into 2, nothing but 48 cc. So oxygen required is 48. How much is formed here? Because 1 volume is there, straight away we can say that 24 cc of CO2 is formed. So we have understood this. 1 volume 24 cc reacts with 48 cc 2 volume and forms 1 volume of carbon dioxide. Now, what is the mixture here? The mixture is CO2 as well as unreacted oxygen. So in the reaction vessel, you know that the product is there and the one which is unreacted oxygen also will be present in the reaction mixture. So how much CO2 you have? 24 cc. And how much is unreacted? 58 cc. So therefore in the mixture we have 82 cc. So which is given. So it will definitely match with the given value, that is 82 cubic centimeter. Hope you have understood this. We have proved with the calculations. So what is required? First and foremost thing, you should know how to balance the combustion reaction. After that you write the volume and it will prove that all these reactants will combine in a simple ratio to give the product. So hope you have understood the question number 5. Let us move to question number 6. Now question number 6. What volume of oxygen is required to burn completely 400 ml acetylene? Also calculate volume of CO2. So this is the given equation. So they have mentioned 400 ml acetylene. So before that let us write 2 volumes of acetylene requires 5 volumes of oxygen and forms 4 volumes of CO2. So because it is liquid you can ignore that. Now 400 ml will require how much oxygen? That is the question. So let us write 2 volume needs 5 volumes of oxygen. 400 ml is equal to x. On cross multiplication what we get? 2x is equal to 400 into 5. Therefore x is equal to 400 into 5 by 2. So you can cancel this, nothing but 1000 ml. So we require 1000 ml oxygen to burn completely with 400 ml acetylene. Hope you have understood the first part of the question. Very simple, they are asking how much oxygen is required. We require 1000 ml of oxygen. Now second one, how much CO2 is formed? For this you can easily understand that if you take 2 volumes you will get 4 volume of carbon dioxide. Let us write that 2 volume of acetylene will produce 4 volume of CO2. Now how much is given? 400 ml. Take it as x. On cross multiplication what we get? 2x is equal to 400 into 4 here. So 2x is equal to 400 into 4. Now x is equal to 400 into 4 by 2. So we get 800 ml of CO2. So very simple. So we have 1000 ml oxygen is required and we will produce 800 ml of CO2 from 400 ml of acetylene. Hope you have understood this. Now let us move to question number 7. Now let us see question number 7. So 112 centimeter cube of H2S, that is hydrogen sulfide gas, rotten X smell, is mixed with 120 centimeter cube of chlorine gas at STP to form HCl and sulfur. They are asking, write the balanced equation and calculate what is the volume of gaseous product formed and total composition of the reaction mixture. First and foremost thing, how to write balanced equation? So H2S gas is combined with chlorine gas and the product obtained is HCl gas plus sulfur, which is solid. We can ignore the solid product. Now you can understand here we have 2, therefore write the coefficient 2 here. Now Cl2 is balanced here, sulfur is also balanced. Now this is our balanced equation. After this, let us follow the usual method. 1 volume of H2S combines with 1 volume chlorine to form 2 volume of gaseous HCl. Hope you have understood this. If it is 112 centimeter cube of H2S, how much chlorine is required? 1 volume, therefore we need 112 centimeter cube of chlorine. Now very important thing, this is 1 and this is 2, therefore easily you can understand that 1 volume is 112, therefore 2 volume is 112 into 2, so nothing but 224 centimeter cube of HCl gas is formed. So hope you have understood this. Very simple. You can calculate separately also. How to calculate? 1 volume of H2S gives us 2 volumes of HCl. If you take 112 centimeter cube, this is x, cross multiply, x is equal to 112 into 2, nothing but 224 centimeter cube of HCl. Either you can follow this or you can directly calculate like this. Hope you have understood this. The first question, volume of gaseous product, that is HCl, how much we got? 224 centimeter cube. Now they are asking the resulting mixture. What is present in the resulting mixture? Nothing but the product as well as unreacted chlorine. So how much chlorine is unreacted? Now let us see how much is given. So initially you have 120 centimeter cube, in that 112 centimeter cube is reacted. So let us write like that. So the product already we are aware of, 224 centimeter cube of HCl gas is present. Now to calculate unreacted, let us see this. So given volume of chlorine 120 centimeter cube. So we are given with 120 centimeter cube. How much volume is reacted? So volume of chlorine reacted, nothing but 112 centimeter cube. So how much volume of Cl2 is unreacted? If you subtract this, you will get 8 centimeter cube. Hope you have understood this. To calculate how much chlorine is unreacted, given volume minus reacted chlorine. So in the reaction mixture, we have 8 centimeter cube of chlorine gas. So this is your reaction mixture. Second question. So we have solved this. Hope you have understood. Now let us move to question number 8. Now let us see question number 8. So 1250 centimeter cube of oxygen was burnt with 300 centimeter cube of ethane. So they have given the equation here, combustion. Now what is the volume of unused oxygen, that is unreacted? First, unreacted oxygen we have to calculate. Before that, let us write 2 volume ethane requires 7 volume of oxygen and forms 4 volume of CO2, and because it is liquid you can ignore water. So what is given here? 300 cc of ethane. So 300 cubic centimeter of ethane. So therefore, how much oxygen is required? First let us calculate. 2x is equal to 300 into 7. Therefore x is equal to 300 into 7 by 2. So this is 150. So how much we will get? So we get 1050 cc of oxygen. So we need 1050 cubic centimeter. So how much is given? 1250. So let us take like this. Given volume of oxygen 1250 cc. How much is required? Required volume of oxygen is 1050 cc. Therefore, unreacted oxygen (200 centimeter cube of oxygen remains unreacted). So hope you have understood this. Next, what is the volume of CO2 formed? Second question. Volume of CO2. Now we know that 2C2H6 gives us 4 CO2. How much they took here? 300 cc. We can write like this. 2 volume. Here it is 4 volume. Take it as x. On cross multiplication, what we get? 2x is equal to 300 into 4. Therefore, x is equal to 300 into 4 by 2. 600 cc. Hope you have understood this now. First and foremost thing, how much is unreacted oxygen here? Unreacted oxygen is 200 centimeter cube. And now how much of CO2 is formed? That is 600 cubic centimeter. Hope you have understood this. Now let us move to question number 9. Now question number 9. What volume of oxygen is required to affect the combustion of 11 liters of ethylene? They have mentioned at 273 degrees Celsius and 380 mm of Hg pressure. Now equation is given. So first and foremost thing is they didn't give at STP condition, so we need to calculate. Let us take this as at STP, P1, V1 and T1 we take. So we need to calculate V1. So STP is 760 mm and temperature is 273 Kelvin. Now for the second condition, so what is the given pressure? That is 380 mm is given and volume is 11 liters and the temperature is, they have given in 273 degrees Celsius. Hence to convert into Kelvin, add 273, so we get 546 Kelvin. Hope you have understood this. Now this we have got it. Now calculate V1. So we know the formula. P1 V1 by T1 is equal to P2 V2 by T2. Hope you have understood this. By applying this formula you can calculate V1. So what is P1 here? 760 into, we need to calculate V1, 273 Kelvin is equal to, what is P2 here? 380. Volume is 11 liters. What is the temperature? 546. To calculate this, send this to other side. V1 is equal to 380 into 11 by 546 into, this gets inverse 273 by 760. Hope you have understood this. Now let us calculate this. 273 1 and this is 2, 380 and this is 2. So we get 11 by 4, nothing but 2.75 liters of oxygen. So sorry, 2.75 liters of ethylene. So at standard temperature pressure we need to add 2.75 liter of ethylene, that is C2H4. Hope you have understood this. But the question is, what is the volume of oxygen required? Now let us substitute this. Hope you have understood. I'll erase this. So we are given with 1 volume, so this is 3 volumes. So 2.75 liters, now take it as X. Let me erase this. The first part of the question you need to calculate V1. Then we will calculate what is the volume of oxygen required. On cross multiplication, X is equal to 2.75 into 3. So 8.25 liters. So we can say that for 2.75 liters of ethylene, we require 8.25 liters of oxygen for complete combustion. Hope you have understood this. Let us move to question number 10. Let us solve question number 10. See, you read the question, try to solve it in 1 minute, then we will check with the solution. Calculate volume of HCl which is formed and how much Cl2 required when 40 ml of methane reacts completely with chlorine at STP. Hope you have understood this. What they have mentioned here. According to the balanced equation, 1 volume of methane combines with 2 volume of chlorine, and this is dichloromethane, and here you get 2 volume of HCl. So this is 1 volume. Now the question is how much of HCl is formed here, that is first one, and they are asking how much Cl2 is required. So given 40 ml of methane is given, so first and foremost thing, how much is required, you can take it as X here. So 1 volume requires 2 volume of chlorine, 40 ml requires X. On cross multiplication, X is equal to 40 into 2, nothing but 80 ml of chlorine gas. Hope you have understood. The first one, what is that? For 40 ml of methane, you require 80 ml of chlorine for complete reaction. Next, how much HCl is formed? Very simple. You can take CH4 is giving you 2 volume of HCl. 1 volume methane forms 2 volume HCl. 40 ml methane, take it as X. On cross multiplication again, X is equal to 40 into 2, nothing but 80 ml of HCl gas is formed. Hope you have understood this. Very simple. To react with 40 ml of methane, you need 40 ml chlorine, and we will get 80 ml of HCl. So let us hope you have understood this. Now let us move to question number 11. So now we are in question number 11. Try to read the question and understand this. What volume of propane, that is C3H8, is burned for 500 centimeter cube of air? They have mentioned air here, and equation is given, but we know that here 1/5 of air contains oxygen. Now let us see this. First and foremost thing, 1 volume of propane requires 5 volume of oxygen, that we know. They are not asking anything in product, so we can ignore this. This was asked in 2017 board exam. Now we have given volume of air. So how much volume is given? 500 centimeter cube. And what is the volume of oxygen present in this air? Nothing but 1/5, 1/5. So we can take it as 1/5 into 500, nothing but 100 centimeter cube. So we have 100 centimeter cube of oxygen. Very simple. In the given question, 100 centimeter cube of oxygen is there. They are asking what is the volume of propane which is required. So 1 volume is 5 volume of oxygen. Therefore take it as X. We want to calculate propane, hence we wrote it as X here. On cross multiplication, we get 5x is equal to 100 centimeter cube. Therefore X is equal to 100 by 5. Nothing but 20 centimeter cube. Therefore what we can write here, So for 500 centimeter cube of air, we have 100 centimeter cube of oxygen. And what is propane required? Therefore, we require 20 centimeter cube of propane. For combustion, how much is required? We need 20 centimeter cube of propane. Hope you have understood this. We'll continue with the next question in the next lecture. Thank you so much. Good morning, students. Today we are going to continue with exercise 5A numericals. In the last class we have done up to question number 11. Now let us see question number 12. 450 centimeter cube of nitrogen monoxide, so NO, and 200 centimeter cube of oxygen are mixed together and ignited. They are asking calculate the composition of resulting mixture. So resulting mixture, what does it include? It includes product as well as any unreacted reactant, any one. Now they have given the equation. In the equation, what we understand, 2 volume of nitrogen monoxide combines with 1 volume of oxygen, and how much product is formed? 2 volume of product. Now they have mentioned here 450 centimeter cube of NO and 200 centimeter cube of oxygen. It's very simple. If you understand 200, so here how much NO should be taken? So it is quite obvious that if 1 volume will require 2 volume, 200 centimeter cube definitely requires 400 centimeter cube of NO. This we know, but how much is given? 450 centimeter cube. And here again 2 volume, so how much you will get? 400 centimeter cube. That also can be calculated like this. 2 volume NO will give you 2 volumes of NO2. Here you have 400 centimeter cube. Therefore, the same amount is formed. That is 400 centimeter cube. So product is 400 centimeter cube. Next, what is the resulting mixture we have? In the resulting mixture we have, first and foremost thing is the product. That is nothing but, here we have 400 centimeter cube of NO2. Now unreacted NO, how much you have left out? Unreacted NO is given is 450. They have mentioned here 450. And how much is reacted? 400. Therefore, you are left with 50 centimeter cube of NO. So in the reaction mixture, finally we get 400 centimeter cube of NO2 product and unreacted NO, which is 50 centimeter cube of NO. So this can be stated as excess reagent. So in theory we have discussed any reactant which is left over is called as excess reagent, and oxygen is completely used up, hence this is considered to be your limiting reagent. Hope you have understood question number 12. Now let us solve question number 13. Now question number 13, you read it and try to solve in less than 1 minute. 6 liter of H2 and 4 liter of chlorine are mixed and water is also added to the gases formed. They are asking what is the volume of residual gas. So what is meant by residual gas? Nothing but the leftover gas. First and foremost thing, write the equation. H2 gas on reacting with chlorine gas, we get 2 volumes of HCl gas. They are not asking about product, they are asking how much is left over. Now with this equation, we know that 1 volume of H2 reacts with 1 volume of Cl2 and we get 2 volumes of HCl. See what is given here. So given volume is nothing but 6 liter of H2 and 4 liter of chlorine. Very simple. Here this is given in less amount, so hence definitely it is consumed and you call it as limiting reagent. Now this is excess, hence you call it as excess reagent, which is left over. So how much is left over we need to calculate. Very simple. If you are taking 1 volume of H2, you need to have 1 volume of Cl2. And here they have mentioned 4 liters. Therefore X, so what will be X? Both are same. Therefore you need 4 liters of hydrogen. Now we have 6 liters, but how much is reacted? 4 liters. So we can write like this: given volume of H2 is 6 liters. So volume of H2 reacted 4 liters. Therefore, what is your residual gas? So the residual gas is 2 liters of H2. So 2 liters of H2 is left over. Hence you call this as excess reagent. Hope you have understood this. So very simple, easy calculations if you are using balanced equation. Now let us move to question number 14. Now question number 14. Try to understand the question and solve it. Ammonia is oxidized to nitrogen monoxide in the presence of a catalyst according to this equation. If 27 liters of reactants are consumed, what volume of NO, nitrogen monoxide, is formed at same temperature and pressure? So given equation, now here 4 volume of NH3, 5 volume of oxygen, together how much we have? 9 volumes. And they mentioned that you are utilizing 27 liters. So for 9 volume it is 27 liters. And how much NO is formed? NO is nothing but 4 volumes. So we can easily identify this. So what is that? If you take the reactants of 9 volume, which is 27 liters, therefore product formed. I am writing in a small steps, you can expand this. Product formed, that is nothing but 4 volume, let us take it as X. Now cross multiply, what do you get? 9x is equal to 27 into 4, therefore x is equal to 27 into 4 by 9. So 9 ones and 9 threes. So what you get? 4 into 3. So we have 12 liters of NO is formed. Very simple question. According to the balanced equation, totally 9 volumes we have. So that 9 volume is nothing but 27 liters. So how much product is formed? 4. So 4 we can take it as X, and on calculation you will get 12 liters of product, that is nitrogen monoxide, is formed. So let us move to question number 15. Question number 15. A mixture of H2 and Cl2 occupying 36 centimeter cube was exploded. So the reaction is taken with 36 centimeter cube of reactants. On shaking it with water, 4 centimeter cube of H2 is left behind. That means it is unreacted. What is the composition of mixture? So in this we have equation, balanced equation. H2 plus Cl2 gives 2HCl. We can write like this: 1 volume of H2 combines with 1 volume of Cl2 and forms 2 volumes of HCl gas. Hope you have understood this. Now what is the total reactants they have taken? 36 centimeter cube of reactants is used. Now how much is left out here? So we know that 4 centimeter cube of H2 is unreacted. So if you subtract this, we get 32 centimeter cube of reactants was used. So we have totally 32 centimeter cube. Now very easy to find out. So H2 plus Cl2 is nothing but 2 volumes. Therefore 1 volume can be calculated as 32 by 2, because 32 centimeter cube is nothing but 2 volumes. So 1 volume is nothing but 16 centimeter cube. So very easy to identify here. We have H2 16 centimeter cube which is reacted, and chlorine 16 centimeter cube which is reacted. And what is the product formed? HCl, nothing but 32 centimeter cube is formed. Now if you are talking about the reaction mixture, what will be that? HCl is formed, right? And then how much is unreacted? Unreacted H2 is nothing but 4 centimeter cube. Hope you have understood this. We have taken 16 centimeter cube of H2 and 16 centimeter cube of Cl2 to form 32 centimeter cube of HCl. So this is about your reaction mixture. Hope you have understood this. We have solved question number 4 to 15 in this lecture, and we'll move to 16 in the next lecture. Thank you so much.